sorry, zener diode and Zener diode. Okay? Today we will discuss about varactor diode. What is varactor diode, everybody? Varactor diode, variable capacitor diode, है ना? Varactor diode is a variable capacitor diode. A diode has a capacitance. We already know. A tiny capacitor resides there in every diode. Okay? So every diode has a capacitor or a capacitance. Every diode has a कैपेसिटेंस. हर डायोड के अंदर एक छोटा सा कैपेसिटर होता है, या यूं कहें कि हर डायोड एक कैपेसिटेंस होल्ड करता है. व्हाट इज द मीनिंग ऑफ कैपेसिटेंस? व्हाट इज द कैपेसिटेंस ऑफ द कैपेसिटर? हाँ, कैपेसिटर ऑफ द कैपेसिटी टू स्टोर द चार्ज, है ना? Capacity to store charge of the capacitor was the capacitance. Okay? So in our diode, we know that every diode has capacity to store some charge. Okay? So for this purpose, don't laugh. Go down. Go down. So we already know that the PN junction diode has a capacitance, and followed by there is a capacitance called diffusion capacitance.
Yes.
In the reverse bias, there is a capacitance called transition capacitance. Although a general
Sir, please detail reverse bias called transition capacity. Please detail, sir.
See, there are two type of capacitance. One is the forward bias, and another is the reverse bias. Okay? In the forward bias, it is called diffusion because that depletion region, that electron from the P region and the hole from the N region, they are getting diffused by the force of attraction of opposite charge. Okay, diffusion.
Yes.
So that capacitance is called diffusion current. Okay, and that the electric field, which is made by that all the electrons shifted from the N to N, N to P and P to N hole, all that depletion region. That also create a depletion region, wider depletion region. That depletion is called the transition. That is formed by the transition of the electron. So in the reverse bias, that transition is called transition capacitance. Okay. Although a general PN junction diode also has a transition capacitance, but it is fabricated in better way than a PN junction diode, so that it can enhance this feature in a better way. Actually, we know that the capacitance is there. Okay? If we need to use that capacitance, if we need to use this feature of the diode, which is stored the charges, so we need to fabricate with the creation, the manufacturing it. Okay? So we need to manufacture it in some special way. Then that feature will be exploited and it will be used in a better manner. Okay? So a varactor diode is a specially designed and fabricated PN junction diode which acts as a variable capacitor under varying reverse bias voltage across its terminal. It is also known with the name varicap diode, varactor diode, or tuning diode. Tuning diode. It is. Excuse me. Fabricated means manufacturing. Fabricated means that what I am giving this one and joining this and manufacturing it, that is called fabrication. Because it is very small, no? The fabric clothes, they are called fabric because it is also that what you call that threads are even so made it that fabric. So like this only, the small P diode, P type and N type, and doping is there, and we are just joining both and making a diode. So it is called, it is manufacturing, nothing but the manufacturing, process of manufacturing. It is also known with the name, okay. It is designed in such a way that its capacitance and the junction changes with the change in the voltage applied across its terminal. And because it is a diode that can behave as a variable capacitor, its name as a varactor diode is short, it is a variable capacitor diode. Very simple. Think like that. If a diode is in reverse bias and or the forward bias, what is the difference? According to on the basis of depletion region.
Yes.
In the forward bias, depletion region will be thinner,
Yeah.
and the reverse bias, depletion region will be wider. Okay. It is always used in the reverse bias, and that's why its transition capacitance is used. Okay. This point, varactor diode is always used in the reverse bias, or because it is used in the reverse bias, only transition capacitance will be used. This is the varactor diode. Okay. The symbol is diode is this one, and we are making a one parallel line, so that it will create a capacitor. It is a symbol of the capacitor, and it is a symbol of diode.
Yes.
Diode with the capacitor. This is the
Right.
varactor. How it will be constructed? See, a varactor diode consists of P-type and N-type. Okay, sandwiched together with the N-type layer attached to the mesa. Mesa means the table-like structure, the flat structure. Mesa, table-shaped structure. A gold-plated molybdenum stud is connected to the N-type layer by the mesa structure, and it acts as a cathode of terminal. No need to read all the things we have already discussed about. It is a revision class.
Yes.
See, this is the varactor. Okay, this flat structure is your table type. This is the mesa structure. Okay, so the P region and N region, and both are connected with the gold wire. Okay, and this one, upper one, this is the molybdenum material. A P-type N-type layer of the varactor diode are made up with the silicon and the gallium arsenide, depending upon the type of application for which it is used. What we'll do, we'll use either silicon or gallium arsenide, depending upon the application on which it is going to use. Okay, for some device, varactor diode will be made of silicon. For some device, we will use gallium arsenide. Okay. For low frequency application, silicon is used. For the high frequency application, gallium arsenide is used, because we know that reverse recovery time of the silicon is more than the gallium arsenide.
Yes, sir.
Okay, reverse recovery time. So anywhere high frequency is concerned, we can't use silicon, because it takes more time in the reverse bias to complete block the current.
Yes, sir.
Getting my point?
Yes, sir.
Normal P-type and N-type semiconductor layers are uniformly doped with the impurities to improve the conductivity. But in the case of varactor diode, the concentration of impurities near the junction is very less, and it gradually increases as we move towards the other terminal. Okay, near the junction it is lightly doped, and as we move towards the terminal, we will get it is more. Okay, your name is Cap? Aman Raj. Why you have not come yesterday with the family?
So there was a competition.
Okay. So he was having the very good news, no?
He's a topper.
He
sir.
missed it.
He's class topper, sir.
Class topper.
Yes.
No, both have same number. Both are class topper.
In all subjects, sir.
In all subjects.
Yes, sir.
Wow.
She's a runner-up and he's a topper.
Aman, why you are not at that just every time when I ask a question, you are not raising your hand to reply. You are a good student. Huh? Okay. Normal P-type, N-type semiconductor layers are uniformly doped, and okay, gradually increase at that side of working. Discuss, if you want to discuss with me. Okay. When reverse bias is applied to a vacuum diode, all holes and electrons moves toward the terminal, which creates a depletion region, which acts like a directed medium of the capacitor, and holes and the electron gathered at the both terminal act like the parallel plate of the capacitor. Okay? As voltage increase, depletion region also become wider. Because depletion region is acting like a dielectric medium, so wider depletion region means more distance between the both charge region. As we increase the voltage, it will increase the width of the depletion region and increase the depletion region. Depletion region like working like the electric of the capacitor. So if the medium is wider, the depletion region is wider, means the distance is increasing between the both plates.
Yes, sir.
Okay. So what happened when that distance will increase? The capacitance of the capacitor will increase or decrease? Decrease. Okay. So when I am increasing the voltage, means I am reducing the
Depletion region.
capacitance of the this capacitor. Isn't it?
Yes, sir.
Okay, see this one. Okay. Inverse in reverse bias, the depletion region is getting wider. So this is already we have seen in that previous class.
Yes, sir.
The CT method. CT means that the transition capacitance, the dq upon dV.
dV.
है ना? Change in the charge,
Charge.
but a change in the voltage.
Voltage.
That is the epsilon A upon W.
Area.
Okay. Where by increasing or decreasing voltage, we can decreasing or increasing capacitance of the vector diode. Although it is diode, but used as a variable capacitor, which is normal capacitor, which a normal capacitor can't work. If you go to market and buy a capacitor, 1000 microfarad or 1000 microfarad, 12 volt. Okay, so its capacitance is fixed. Okay, capacitance is fixed. But here we can change the capacitance of the capacitor. Whose voice is? Where is the sound coming? Outside. Okay. Here is the VI capacitance, VI characteristic of the varactor diode. Okay. When we are increasing the voltage minus to reverse voltage, we are increasing, and CT capacitance of the in the picofarad. This is the picofarad. Okay. Because it is minus means reverse bias. This minus means reverse bias. The relation between the capacitance and the voltage provided is given by the equation. CT means capacitance, transition capacitance equal to K upon Vk plus Vr, all to the power n, where Vk denotes the barrier potential, Vr is the reverse applied potential, and n is a constant that depends upon the doping level. Okay, n depends upon the doping level. The n is a constant that depends on doping level. It usually its value is 1/2, that is a half for the Allard junction, and 1/3 in the case of diffuse junction. There are two methods for the fabrication. One is Allard junction method to fabricate, and other is diffuse junction fabrication. Okay, there are two type of method by which the varactor diode is manufactured. Okay, so the value of n, that is the doping level, it is half for the Allard junction method and 1/3 in the case of diffuse junction. Okay. Application of the varactor diode: television receiver,
Yes.
radio receiver, frequency multiplier, okay, voltage control oscillator, parametric amplifier, phase locked loops. These are the devices used in the our analog signals, transmitting signal, receiving signal, shaping the signal. Okay. Advantage: low noise. Low noise portability. This is very small. It is very small size if you compare with the capacitor. Okay, because diode is also very small size. It is very reliable. It is very reliable. Economical, it is very cheap.
Cheap, yes, sir.
Okay, then we
Power
move to the power diode. Power diode. Anybody have remembered power diode? Can you speak?
Yes, sir. Power diode, in power diode, high voltage on current is used. Power diode, its construction is top of the layer is highly doped P-side semiconductor, which is shown in the P plus, and middle layer, which is N-type semiconductor, which is shown is N minus, and the third layer, which is highly doped N-type semiconductor. So, is a construction of the power diode.
Okay. See, sit down. Very, very good. Basic of power diode. See, power diode means what? It is for
Power semiconductor diode.
power semiconductor. Actually, see, this is for power electronics. Okay, power electronics. In that power electronics, we studied about the every component with the high power, the capacity of the high power which can be used in the high power. High power means the more voltage, the more ampere.
More ampere.
Current will be used for that. Okay, this is the basic electronics. Basic means basic electronics. This is the power electronics also. Okay, the power diode is a power semiconductor device which is made to work on a high voltage and a high current. Their current and the voltage handling capacity is very high. Switching speed of these diodes are less than general diode. Okay, switching speed means blocking the current in the reverse bias. When that current is coming from the forward bias to the reverse bias, how much time it will take to block the current in the reverse bias. That is the switching speed. So the switching speed of these diodes are less than general diode. Power diode are also similar to the normal diode but have a little difference in its construction. Power diodes are required to conduct several kiloamperes of the current in the forward direction and very little power loss while blocking several kilovolts in the reverse direction. What is the meaning of that blocking several kilovolts in the reverse direction? Very little power loss. What is power loss?
Sir, in forward bias, it blocks some of the current and
That's the potential barrier.
yes, sir, that is.
Potential barrier is less, that it will be very little power loss. Large blocking voltage requires wide depletion layer in order to restrict the maximum electric field strength. Power diode consists of three layers. Top layer is a heavily doped P layer, which is shown by the P plus. Middle layer is lightly doped N layer, shown by N minus, and the last layer is the heavily doped N layer, shown by the N plus. The heavily doped P plus layer acts as an anode and N plus layer acts as a cathode. Okay? See here, P plus layer, it is the highly doped. Okay? E, it is lightly doped, it is again highly doped. Okay? See the the reverse recovery characteristic. What is the reverse recovery characteristic? Again, switching. Reverse recovery. Reverse recovery. What is reverse recovery?
How much time to take?
No. Let somebody else tell. Tyra?
Switching very fastly in P region to R region.
Reverse recovery, yes. Reverse recovery means when that polarity gets changed from forward bias to reverse bias, how much time the diode is taking to block all the current in the reverse bias. That is the, right? Very simple. Many times I am telling you. This will come in a come like one number question. Okay. There is a accumulation of the electron in the P region and of the hole in the N region. That is the capacities of the diode. When forward bias is applied to the power diode, it takes short turn on time before the PN junction. PN junction carries full forward current. This time is in the term of nanosecond. Similarly, when reverse bias is applied to the turn of the power diode, it takes short turn on time also before reaching full blocking mode. This time is term of microsecond. Depending upon the reverse recovery characteristic, power diode are categorized in 3 types. Okay, all we have shown that we have seen the Scotty diode also. Okay, fast recovery diode means the diode which is used in the high frequency current. Okay, where the very frequency is very high and we need very fast recovery, so we will use the fast recovery diode. And here the general purpose diode, which we have already gone through, that simple PN junction diode. Okay, general purpose diode have a comparatively high reverse recovery time when compared to other diode. Okay, with high recovery time, then in which circuit it will be used? It will be used in a low frequency circuit. Okay, the frequency is low, then it will be used. Okay. Due to this reason, they are used in the application which are not time critical and generally run on low speed. Usually, the reverse recovery time for the general purpose diode varies between 20 microsecond to 30 microsecond, which is quite a lot. Typical low speed application for general purpose diode include a power diode being used as a rectifier on a or in a converter where the frequency input is quite low. In our case, in our telephone charger or TV or any this is considered 50 hertz only. This is considered low frequency current. Okay, so we don't need for the rectification and all. We don't need to use high frequency diode. Okay, because high frequency diode is due to doping level and all, and fabrication cost, it will be costly in comparison of general PN junction diode. So this current for ourselves, making some eliminator or some rectifier or battery charger, everything, we don't need the fast switching diode. Then simple PN junction diode is enough. Okay, so usually the reverse recovery time for the general purpose diode is 20 to 30 microseconds. And the typical low speed application for the general purpose diode includes the power diode being used as a rectifier or in a converter where the frequency input is quite low. This is for general purpose diode. Power diode, this is for again PN junction. The diode current rating will be 1 ampere to several thousand ampere. The voltage rating will be the 50 volt to 5 kV. Some of the application are general purpose diode are battery charger, charging circuit, uninterrupted power supply, that is UPS, and electrical traction etc. Fast recovery diode. In the diode where the recovery from the forward bias and the reverse bias, it is very fast.
Yes, sir.
It is very fast. At the name indicates, these diodes have very low reverse recovery time. It will be less than the 5 microsecond. They are mainly used in the switching circuit like choppers, communication circuits, switching mode power supply, SMPS. It is the current rating of the diode will be 1 ampere to several thousand amperes. The voltage rating will be the 50 volt to 3 kV. In this type of diode, for low voltage rating below 400 volt, the epitaxial process is used for the fabrication. For diode having the voltage rating above 400 volt, diffusion techniques is used for the fabrication of diode. Next is Scotty diode. Scotty diode we have already in our syllabus for the introduction purpose here. In high frequency, see how many diode we have seen where P and N is not there. Both semiconductor is not used.
Yes.
Only one semiconductor used. Out of that, this is also used on the uni junction. This is also uni junction. The high frequency switching like SMPS, the Scotty diode are used in those applications. We can't use the general purpose diode. In this type of diodes, instead of PN junction diode, मतलब semiconductor to semiconductor diode की जगह पे metal to semiconductor diode is used. The cathode diode have very fast recovery time and low forward voltage drop because it is used. It is made by only unijunction. The depletion region is not there. So very thin depletion region is there. So potential barrier is very less.
Yes.
The capacitance is also very less.
Yes, sir.
That's why in the reverse recovery it will very fast switching. Scotty diode is mostly used in a low voltage and a high current application such as DC power supply and rectifiers DC. The current flow will be done by only majority carrier, so the time delay due to reverse recombination is avoided. The drawback with the Schottky diode is that they have low voltage rating around 100 volt only, and the forward current rating is up to 300 ampere. Okay. See this chart. General purpose diode, voltage rating, current rating, and reverse recovery time is here. You can compare Schottky diode less than 15 nanosecond. This is the microsecond, and this is
25 microseconds.
okay. It has low forward bias, 0.3 to 0.5 volt. Because many authors have written only 0.3 volt. Okay. Somewhere you may get that 0.2 to 0.3 to 0.7 because it is depending upon the fabrication method also.
Yes, sir.
Okay. Fast recovery
Fast.
time, fast switching, high reverse leakage current.
Yes.
Okay. Used in the high switching device such as SMPS, high power application where good efficiency required. It is unipolar diode because it has only N-type semiconductor. Anode, metal, and N-type. P-type is not there. Okay. Photodiode. What is photodiode? Aman,
Light sensitive diode.
this is light sensitive diode. Okay, tell me more. You tell.
Consume light and convert it into digital.
Consume light and convert it to the electric energy. Okay, you may tell it. Okay. Photodiode. What is photodiode? Actually, in which direction it will be used? The forward bias or the reverse bias? Forward bias or reverse bias? Forward bias?
Yes.
Sure?
Yes.
Pakka?
Yes.
Lock.
Who believe that it will work in the forward bias? Raise your hand. Only you. You also. In the forward bias, it will work like a simple diode. In the forward bias, it will work like a simple diode. In the reverse bias, it will work like a photodiode. Okay? How? Can you do? Speak.
So, sir, may I repeat your question?
Huh? You want to ask question?
No, sir. I ask you, may I repeat your question?
I'm just asking about the photodiode. How it is working. The working process of the
Then
photodiode.
the light is entering into electron, then electron gets some energy and it will move from inside to this side.
Okay, see,
And this is transparent potential
if
barrier.
if I connect a diode in a reverse bias, okay, so the depletion region is wider,
Yes.
and it will be at same potential where it will be at same potential after some time as the potential supplied, but in a reverse direction. If I am using 5-volt battery, after it will take some time, some microsecond. It will reach again the depletion region will be having the 5-volt potential barrier. Or I am connecting 5-volt battery. 5-volt battery connected with the diode, whose potential barrier is 5 volt. Connection will occur? Connection will occur or not?
will occur, but for cases.
See what I am telling. Okay, so it is 5 volt. Okay, it is 5 volt, and diode is now in a complete blocking mode. So means the current is not flowing. That means that the battery 5 volt we are providing like this, and here this depletion region also have a 5 volt barrier.
Yes, sir.
Okay, if that barrier is 5 volt and I am just want to supply that 5 volt, how that this 5 volt will overcome this 5 volt and get this side?
No, sir.
Not possible?
No, sir.
Not possible, no? Okay. Now I am just increasing the 6 volt. So sometime I will get here 1 volt. At same time that will again it will increase depletion
Yes.
and create the potential back to 6 volt.
Yes, sir.
Okay. So if any process, मतलब किसी तरह से anyhow, if we just decrease the potential barrier, or decrease the width of the depletion region, that conduction will start.
Yes, sir.
Conduction will start.
Yes.
Okay. Here is electron. Here this region is
Depletion is plus.
okay. Here is plus. Or here is minus.
Minus.
Fine. What in the region, what we are doing here in the photodiode, near the depletion region, we are making the transparent wall. This is transparent. This is transparent, and if the light enters the transparent from the transparent layer inside the diode, what happened in this hole and the depletion region, that the atom has a hole. When that electron, that energy came inside the diode, what happened? That this atom will release one more electron after getting the energy. It will, okay. What is happening? If an atom is there, and the atom, the outer orbit, electron are moving. If you are giving the energy, either it is a heat energy or electric energy, anything. So when that after getting the energy, that will start oscillating faster. It will just jump out from the orbit.
Yes.
Okay, that become a free electron.
Yes, sir.
Okay, so here that free electron will create after this light. This intense light, free electron will be created. Okay, and that free electron will decrease this region, because they are all are the plus, all are giving the extra electron.
Yes.
So it will remove. It will create
This.
it will reduce the width of the depletion region,
region.
and that's why that potential barrier created, it will be also reduced.
Yes, sir.
Okay, let us suppose we have given some light and it will reduce us. This is a bit, and the potential barrier decreased to 4 volt.
Yes.
4 volt. Then we will get 1 volt here.
Yes, sir.
Okay, some more light incidence in the diode. It will again reduce. it will get 3 volt, 2 volt we will getting, 3 volt we will be getting. As soon as it is the 0 volt, it will not come to 0 actually, it will have reduced greater than 0. Okay, greater than 0, it will be greater than 0. So what we are getting here, it is less than equal to 5 volt. It will not increase more than 5 volt.
Yes.
Because what the voltage we are getting, it is actually supplied voltage from the battery. Okay, it is like door. Opening a tap maximum, it will give you the water a lot,
Lot.
or we are just tightening the,
Filter water.
it will reduce the water supply. That is like only.
Yes.
Understood?
Yes.
Yes.
Getting my point? So this is all about the photodiode. A photodiode is a p-n junction diode that consumes light energy to produce electric energy or to produce electric current. Sometimes it is also called a photodetector, light detector and photosensor. These diodes are particularly designed to work in a reverse bias condition. It means that the P side of the photodiode is associated with the negative terminal and of the battery, and the N side is connected with the positive terminal of the battery. This diode is very sensitive to the light, so when light falls on the diode, it easily changes light into the electric current. So there is a transparent wall at the depletion region to enter light. This is the photodiode. Okay. So what is the symbol of photodiode? Making a diode and showing two indistinct arrow showing the light. Okay. See, in the reverse bias, for very less time, less current flow, which is called transition current. We are feeling like that I'm in a mela and sitting on the jula.
Yes.
Okay, see. Okay. Electron and moving electron to this one, and this hole is filled up, and this location, because the electron has passed out, so it is positively charged. This region will be positively charged, and this, because the electron came here, and it is filled all the hole which was earlier positive charge. So here positive charge removed means negative charge. The depletion region, see? Okay? Transient current. What present? See here, light is coming inside, and it will just 4 electrons for the silicon. It will energize 1 electron, and that electron will be freed from the atom. Okay, and that hole will be created after that electron will be freed, and from the P side, from the this side, depletion region, from the P side, lot of electrons are there. Just behind the depletion region.
Yes, sir.
That electron will fill that hole.
Yes, sir.
Here electron. Why, Prashant, you always keep smiling? Now, wear mask. You also. Everybody wear mask. Don't forget. See, because I am going in many classes. All the classes have 50 students. So have, no.
Yes, sir.
So, protect yourself. Protect yourself. Okay. Understood now? This one?
Yes, sir.
Light enters and energizes 1 electron from the atom. It jumped out from the orbit, and that electron will fill the electron. The free electron is here, and the free electron from the P side entered the N side to fill that hole. Okay, so that will randomly come and repeatedly come. It will repeatedly come, repeatedly happen. Then what will happen? So deflection region width will be
Reduce.
reduced and potential barrier also reduced.
Yes, sir.
When potential barrier reduced, we'll get the voltage.
Yes, sir.
Okay, energy of the photon is derived from the formula equal to H, E equal to H
H nu.
nu, where H is a Planck constant and the Greek letter nu is the photon frequency. Okay, that depends upon the frequency. Frequency means light, the color of light, all the color of lights are having different frequencies.
Yes, sir.
So it will depend upon
The
the
frequency.
color also.
Yes, sir.
High the frequency will create more energy. Okay? So the Planck constant denoted by the H in the physical constant, that is the quantum of the electromagnetic action, which relates the energy carried by the photon to its frequency. Our photon's energy is equal to the frequency multiplied by the Planck's constant. Therefore, the photon energy at 1 hertz, actually, this is the example. Okay, there is no light with the 1 hertz. If a light, just consider a light at 1 hertz, then the frequency will be 4.135777516 into 10 to the power minus 15 electron volt,
Electron volt, yes.
or it is in the joule.
Yes, sir.
Okay, electron volt matlab it is compared with the volt of voltage created by the one electron. Okay,
So what is the meaning of quantum? Quantum physics?
But
which quantum?
quantum,
Quantum.
photon or quantum.
H is the physical constant, that is the quantum of electromagnetic action. See, for the Planck constant.
Yes, sir. So I will define.
Uh-huh.
But in English.
Tell me that, excuse me for not using English and speak.
प्लैंक जो थे एक मतलब वैज्ञानिक थे लेकिन
हाँ, प्लैंक एक
उन्होंने कहा कि प्रकाश से सूरज की जो किरणें आती है वो छोटे छोटे कोणों में डिवाइड होती है, इसे क्वांटा या फोटॉन कहते हैं, वही क्वांटा है। और प्लैंक कांस्टेंट h का मान होता है 6.25 × 10⁻⁻14 वो वाला मान है। वो प्लैंक कांस्टेंट का मान जो कांस्टेंट होता है और भी फ्रीक्वेंसी
It is given E, the energy is proportional to the nu.
New.
New.
It
Yes.
is nu. Okay, when we put the proportional sign with the equal to, we put the constant. That constant is given by the Planck.
Okay.
That equation is proportional to the frequency of the light is given, and E that put that H there for the constant. Okay. Weak characteristic of photodiode. A photodiode continually operates in the reverse bias mode. The photocurrent is nearly independent of the reverse bias voltage which is applied. For zero luminance, matlab zero light, if there is a zero light, the photo current is almost zero. The photo current is almost zero. As optical power rises, the photo current also rises linearly. As we increase the light, intensity of the light,
Yes, sir.
that current also increase in same manner, some linear manner.
डायरेक्टली प्रोपोर्शनल सर।
Somebody written high. Okay, see. At the zero level, the dark current, zero level, the dark current means there is no light, so no current. Okay? And we are increasing the
वोल्टेज
we are increasing the intensity of the light, the lumens, and we are getting the voltage. We are getting the voltage. नहीं समझ में आ रहा है, क्या समझ में नहीं आ रहा है? It is a revision class actually. क्या समझ में नहीं आ रहा है बताएं आप? Okay, somebody has written there, so समझ में नहीं आ रहा है. Okay, so photodiode Yes, because it is a revision class only. So I am just revising everything. We have conducted class and that class also on the YouTube channel. Okay, so
What is his question, sir? What is it?
Reading that class is going on. Because I am reading already now. I am reading, explaining everything already explained to you.
Yes.
So you need to know the reverse bias, forward bias, reverse recovery time, everything is clear.
Yes.
So that's why. Okay, so it is our VI characteristic of the photodiode. Here we see that the zero luminance, there is a direct current. Okay, there is no current. Direct current means no current. No current. As we increase the light intensity, we see the rise in the voltage. There is a voltage. Okay. So as it will increase linearly. So the light will increase, the intensity of the light increase, and the voltage will also increase. Right? What is the application of photodiode? Tell me. It is used in the CCD, charge coupled device. What is a charge coupled device? It is used in the electronic camera, the digital camera. This device is used. Okay. A photoconductor and photomultiplier tubes. These diodes are used in the consumer electronics device like smoke detectors, compact disc player, and the television remote controls.
Yeah, television remote controls.
Okay.
Yes, sure, sir.
In other consumer devices like camera, lights, meter, and street light, any type of devices which you need to be a light sensitive, it will use either a photodiode or a phototransistor.
Yes.
Photodiode or phototransistor. We will see the phototransistor also. Okay, we will start the topic. Okay, photodiode are frequently used for the exact measurement of the intensity of the light in the science and industry. Okay. If you have any doubt, you
Can ask
at
that.
the same time you can ask the question.
Yes.
Photodiode are also widely used in the numerous medical appliances like instrumental to analyze samples, detectors, and computed tomography, and also used in the blood gas monitor. These diodes are much faster and more complex than the normal range diode, and hence are frequently used for the lighting regulation and the optical communication. Optical communication. Okay. Next one is the LED. Next one is the LED. Light emitting diode. It is also a diode, but emit light. It will emit light. Okay. This class you have attended? No, this also you have not attended. Why? Why you have not attended the class? Okay. LED. LED. Okay. Have you remember that direct gapping or indirect gapping semiconductor? Direct gap semiconductor or indirect gap semiconductor? Not remember? Anybody? Direct gap and indirect gap? No. Okay. So energy, the gap, energy gap between the semiconductors, valence band energy and the conduction band energy, the gap between energy, the gap between both energy level, etc. Huh?
Yes.
Okay. So what happened when two semiconductors, then if actually P and N, there are two type of semiconductor. We both collect it and we tell it the diode. We named it a diode. Okay. So inside N type of semiconductor, and the P type semiconductor, when an electron from the N side is moving to the P side hole, okay, so there is some basic.
There are needed some energy.
No, see, if atom, this is atom, okay, and here is the electron. So is having some energy level?
Yes, sir.
Is have some energy level?
Yes, sir.
If we give some energy to this electron, it will evaporate and it will come,
Another
it will leave the orbit. It will leave
Um,
the orbit. Okay? So just think that this is the hole and that electron is here. This electron is here. So what was the its energy level when it was in the orbit and what is the energy level now? That is the difference. Okay? Now here is the energy level. It's the more energy level. It is at the more energy level when it was in the orbit.
Yes, sir.
Yes, sir.
Okay? So, when it will come again to the orbit? When it will come again to the orbit? When it lose energy?
Yes, sir.
Yes, sir.
Low energy. Okay? Understand that? The same level of energy, it won't come to the pole. Because for that energy level, he jumped out from the orbit. Okay? So think about the p-n junction diode. One electron from this side to move this side
Yes,
means what? Here the hole is here,
Yes, sir.
electron is here,
Yes, sir.
and you need to fill the gap, fill the hole.
Yes, sir.
Okay? So here it is the conduction band, it is the valence band. If the electron is coming to this hole and both energy level are not equal, then that if that electron are moving here, you will lose some energy.
Yes, sir.
It will lose some energy. Suppose here it was when that electron is here, it having the, for the example, it was, that electron was having 5 electron volt.
Yeah.
Okay? And now it is having
7.
7 electron volt. Okay? Anyhow, if it comes to here, it will lose
You will lose
2 electron volt.
electron volt.
Yes.
Okay? This is the important thing for the LED. Okay? In every diode, when we conduct, all the electron moves from N to P. Then circuit will complete. Okay? So if when the electron move from the conduction band to the valence band, it will every electron will release some energy. Will release some energy. Okay? So why that question will arise afterwards. Understood? No?
Yes, sir.
Okay. LED is nothing but the same semiconductor device. This PN and this is the PN and okay. So very good question. When the LED produce light, why only LED produce light? What about the other diodes? Because the conduction band is there, valence band is there, electrons are moving from the conduction band to valence band. In the every diode, that electron comes to the orbit, it will lose some energy.
This question is in mine, sir.
Huh?
This question is my mind.
Huh? Question.
No, sir. This question.
This question is aligned in his.
Acha, you all,
Yes, sir.
already thinking.
Yes, sir.
We have discussed this. That the when we are talking about LED, that question was discussed. Okay? What happened? For the light is also electromagnetic wave, electromagnetic energy. All the electromagnetic energies have amplitude, frequency, and wavelength, and etc. etc. Huh? All have this property.
Yes, sir.
Okay, so which wavelength a man eyes can see? If that energy is producing equivalent to that that level, that the radiation will be seen by us.
Yes, sir.
Otherwise, it will be a ultraviolet. It will be a wavelength beyond our visible range. See, I show you the visible range.
I think so.
This one, this one only visible range. Okay, if that energy is in this range only, then only that light. If there is the light, we can feel that here the light is coming from this LED. We can feel. Otherwise, always there are a lot of infrared and radio and all actually. So infrared means what?
Very high frequency light. They are
See,
very
if
high
you
frequency.
use any diode, the circuit, you will feel like it is getting heated. Okay, that is infrared. That the energy comes loses from the electron, it converted to the heat. So a special type of semiconductor used to fabricate LED. Okay, that's why the light is our visible. Okay, LED stands for the light emitting diode. The light emitting diode is made by the PN junction diode semiconductor. In 1962, Nick Holoniak has come with an idea of the light emitting diode, and he was working for the General Electric company. That LED is a special type of PN junction diode. Hence, the LED allows the flow of current in the forward direction and blocks the current in the reverse direction. The LED occupies the small area which is less than the 1 meter per square. The application of LED is used to make various electrical and electronic projects. Okay, this is the LED transparent, because if it is generating light, the outer layer should be transparent. So that light becomes out. Yeah, it can go out. See, this is a P-type and N-type, like triple diode. When LED, just like normal PN diode, the connected the forward bias free electrons, and the N-type moves to P. We should not discuss about it. We have discussed many times. So I am directly coming to basic conduct. This is the conduction band, this is the valence band, this is the forbidden energy. If the electron coming from the conduction band to the valence band, it will lose some energy.
Yes, sir.
Yes.
What we have studied in the insulator, because this gap is very, very wide. This gap is very wide. Electron in the conduction band is a heavy energy, high energy, and the valence band is very low energy. So electron cannot release a huge energy. Electron cannot release. It may release only some fixed energy. There is a limitation that how much energy can an electron release. So there is a very much difference. So that's why the conduction is not happened in the insulator. Okay.
Yes, sir.
Okay. One more thing. There are two types of
Energy
semiconductor.
of 0.6 electron volt. So it is very long gap, and semiconductor energy gap is 0.3, 0 to 0.3 energy gap. So semiconductor.
No. Tell me again.
Can you speak in English?
Uh-huh.
मतलब इंसुलेटर का जो एनर्जी गैप होता है ना, सेमीकंडक्टर का काफी ज्यादा होता है, 0.6 तक चला जाता है, इस वजह से वो विद्युत धारा का प्रवाह नहीं हो पाता, और सेमीकंडक्टर का जो एनर्जी गैप होता है 0 से 0.3 का होता है, जिसके कारण हम लोग डोपिंग की सहायता से डोपेंट मिलाकर धारा का प्रवाह कर सकते हैं.
ठीक है. तो here this is the conduction band. When electron is coming from the conduction band to the hole in the valence band, it will lose some energy.
Yes, sir.
Okay. That energy, that lost energy, that lost energy from the electron, it will be used as a energy for the lighting or other energy source. Okay, this is the same thing. That A is the proportional to the frequency of light, and the F barabar C upon lambda, where the C is the light of the speed of the light and lambda is the wavelength of the light. Okay, Eg is C upon lambda and all. Okay, have you any doubt?
Yes, sir. I can sense.
Okay. This is the our all electromagnetic wave range. Okay, what is the wavelength? A human eye can see.
See.
Okay, one more thing. The main topic I want to show you this one. Direct semiconductor gap and indirect semiconductor gap. What is the difference? In the direct semiconductor gap, the electron at the conduction band, all the electrons we have shaped like this only because the electron at the low in that conduction band, all electrons are not will be at same energy level. Okay?
Yes,
Some are high, some are low. So upper one is the high energy level, and this one is the low energy level in that conduction band. Okay? In here, what we are taking, all are hole. Hole are the hole, which hole have the maximum energy at upper layer or lower energy here. So this is the electron which has the very low energy and the conduction band. Okay? Here, this atom has the very, this
High.
orbit has a high, it is the valence band and it has the high energy. So the difference will be very less. Okay? The difference between this and that is a very, very big. It is very high, it is very low.
Yes, sir.
Okay? But here it is difference is very low. So that electron can fill that hole. Okay? What? Okay. So when this is direct gap, means that electron will move directly to the hole. Okay? All the energy he lose, that electron lose, it will be created as a, it will be seen as a light. But what happened in indirect semiconductor? In that semiconductor, the electron, here the electron, or here is a hole. Okay? Here he need to fill this one. What happened? He will go like this and this one. So it will create a momentum, and that momentum lose all the energy what he lose.
Yes, sir.
So that it will remain a very less energy, and so it will create a electromagnetic in a very small wavelength. So we can't see that light. We feel that light, we feel that energy as a heat. Okay? Anything else for the LED? Silicon and germanium semiconductor are not direct gap semiconductor, they are indirect gap semiconductor. Silicon and germanium are indirect gap semiconductors, so it is not used for the LED. Okay? This is wavelength color. This is normal diode, lighting diode, gallium arsenide, gallium phosphide, gallium arsenide phosphide, silicon carbide and gallium indium nitride. These are the special semiconductor which is used for making LED. Okay, what is the time?
And lunch break is also over, sir.
Okay.